Well, now, I want to ask you a question. It might seem a bit of a funny question. The question is not, why am I standing here with a balloon in my hand? The question is this: what does the balloon that I'm holding have in common with a Diwali rocket that at Diwali time you see fired up into the sky? And what does it have in common with the rifle and the pistol that you see here? And what do all those three things, the balloon, the Diwali rocket, a gun and a pistol, what do they have in common with the Drucker Airbus? Well, the answer is, what they all have in common is that they work because of Newton's third law. And you'll remember that Newton's third law says that to every action there is an equal and opposite reaction. So let's just look at the balloon. I give energy by squeezing the air in the balloon, and then when I release the end, the air rushes out backwards. Why? Because the elastic of the balloon exerts a force backwards on the air. But remembering action and reaction, if the balloon exerts a force back on the air exerts a force forwards on the balloon. Action and reaction. With a Diwali rocket, you light the blue touched paper, taking care not to put your head over the rocket, otherwise it may go up your nose. And hot gas comes out of the back of the rocket. The rocket is exerting a downwards force on the gas, but the gas is exerting an upwards force on the little rocket, so the rocket shoots into the sky. Let's look at a bullet, which fits into this AK-47. Inside the bullet is gunpowder, and when the bullet is fired in the AK-47, the hot gases from the gunpowder exert a forwards force on the bullet, but action and reaction, the bullet exerts a backwards force on the gun. So action pushes the bullet out, the reaction of the bullet on the shell case and the gun pushes the gun backwards. And in a moment, we're here at Detchen Scholing and we'll see this AK-47 fire this bullet. And when you hear the bang, I want you to imagine this bullet coming out forwards very, very fast. But I also want you to think of the reaction of the bullet backwards on the gun, and you'll see the gun kicks backwards. The same with the pistol. In fact, we'll begin with the pistol because the action and reaction are a bit more obvious. And if you've watched lots of films, you'll see that people come along with their pistol like this. And as you'll see, if you just use one hand, you will see the reaction. And then we go to the Airbus, and I'll talk a little bit more later about the jet engine, which works in a way just like my pink balloon, action and reaction. A jet engine is known as a reaction engine. So let's watch the action and the reaction with a rifle, with a pistol. Let's begin with a 9mm pistol. So here we are at Paro Airport, and Captain Sonam of Druk Captain is with me here. He's just brought in the plane you see behind us from Bangkok. So let's welcome Captain Sonam back to Paro, and I hope, Captain, you can answer a question for me.
Sure, thank you for having me in your program.
A pleasure. It's lovely to see you.
Nice meeting you too, sir.
Now, Newton's second law tells us that force equals mass times acceleration. Tell us all, what's the mass in kilograms of an Airbus on a typical day when it actually takes off?
Okay, the maximum takeoff weight out of Paro is 60 tons. 60 tons, it also depends on weight at ambient temperature and the pressure altitude we have in Paro. So we are restricted to a lot of factors when we take off out of Paro. 60 tons is the maximum figure we quote, but we have a book, a manual, which tells us exactly how much we can take off out of Paro.
Thank you, Captain Sonam. And each of these jet engines produces a force called a thrust of about 175,000 newtons. So 2 engines, that's 350,000 newtons. So we know the force, 350,000 newtons. We know the approximate mass, about 60,000 kilograms, between 50 and 60,000 kilograms. So using Newton's second law, force equals mass times acceleration, it means we can actually calculate the acceleration of the Airbus down the runway. And as Captain Sonam says, it depends on air temperature and air pressure. Would this be why sometimes the Druk plane cannot fly with full capacity, with not every seat filled?
Exactly, that is why most of the people don't understand saying that they have seats in the plane, but yet they don't carry passengers. But I want to make it clear once again, we are watt limited, weighted ambient temperature, so therefore we have a lot of restrictions carrying full load out of Paro in a hot, heavy, I would say a hot day and a heavy aircraft. So we have to, supposedly if you are flying to Bangkok, we need to take a lot of fuel. In that way we have to cut down the passenger seats so that we have enough fuel to reach us to Bangkok. So we are unable to carry the whole lot of passengers which we are supposed to carry.
Right. So next time you or your parents might travel on Druk and be told there were no seats available, and then you see empty seats on the plane, now you know why. It's all to do with how hot the day is and what the air pressure here at Paro Airport is. So that's another physics lesson, isn't it? Because at high temperature, the air is less dense than at a low temperature. And so the aeroplane wings don't get as much lift as they would get if the air was denser at a lower temperature. Thank you, Captain Sonam, very much. Enjoy your break.
And thank you once again for having me in your program, sir. Good luck. Thank you.
So what's inside a jet engine? How does a jet engine work? Well, it's really very, very simple. A jet engine consists of 2 fans and a flame. Whoops, my flame has just gone out. This sometimes happens in a jet engine too. It's called a flame out. Well, because of the wind, and this is only a candle, I'm not going to bother to light it again. But imagine there's a flame. Now, at the front of the jet engine is 1 fan here. And at the back of the jet engine is another fan here. This fan sucks in air from the front of the plane. The air comes out here. The flame that you can't see heats up the air to a very high temperature, and the air expands. And it expands and pushes out through this fan very fast, and it comes out at the back of the engine there. So we have air coming in, being heated up and expanded and pushed out very, very fast from the back of the engine. Now, just think for a moment about the gun and the bullet. The bullet came fast out of the gun, and it pushed the gun the other way. Action, reaction. This is exactly the same. The air's being pushed out there, action, but the air is pushing the engine this way. So therefore, the hot air being pushed out of the back of the engine very fast, pushes the engine forwards, and the engine is attached to the plane, so the plane moves forwards. So that's how a jet engine works. 2 fans and a flame. So very, very simple. It's called a reaction engine because it depends on the reaction of the hot air on the engine. It's the reaction that pushes the plane forwards. And of course, a real jet engine is more complicated than 2 fans and a candle. You wouldn't get very far on the way to Bangkok with 2 fans and a candle like this. But the principle of its operation is just like this. There's one very clever thing. What makes this fan go round in a real jet engine? Answer. This fan is connected with a rod to that fan. So when the hot air rushes out of here and makes this fan go round, it also makes that fan go round. And that's how the jet engine keeps going. You don't need an electricity supply to make the fans turn. The energy for all this comes from the flame, which is the result of the fuel burning in the middle of the jet engine. That's where the energy comes from, the jet fuel. Let's look at, very quickly, a picture of the inside of a real jet engine, and you'll see that fundamentally it's 2 fans, a fan in the front, a flame in the middle, and the fan at the back. So even a jet engine is quite simple. And I've just explained it in English. The national language of Bhutan is Dzongkha. So let's have a quick explanation in Dzongkha.
당아치기 남두기 치치디 가데베 라비오 나가기 종하나 도디베 슈겔라나 체솔로 땡아치 남두기 치치나루 룽코 니비올라 동카치다 잡카치베 데 룽코 니기 분알루 텔레 마쿠데서 갸라 차돔소사 치치지올라 데 동하기 룽코 디날레 룸디스 나메 사메 슈비텐 텔레 룸디스 나나시올라 텔레 마쿠 디인디기 룸디스 갸 나메 사메 차돔소 텔레 남섬 디소 텔라나 잡카기 룽코드나레 텐조달로 아메 섬이 슈베 텐조라 때 슈베 텐조달로 같이 남도디 메신지가 그들 아니 친디기 남도디 슈베 피동라네 잡카기 룸디기 슈기베 단베니 같이 따오달로 남도디 따오달로 남섬 라가비 톰맘 때 라베오다 난고날 라베오다 가데베 라베오나 티수게 알아 같이 좀 동동베 하고 습세 신이
So I just want to summarize for you very quickly what we've looked at in the last 2 programs. We've looked at Newton's laws of motion. And I'll abbreviate Newton's laws of motion to NLM. And we saw there are 3 Newton's laws of motion. NLM 1, NLM 2, NLM 3. We've seen that Newton's first law of motion tells us that an object remains stationary unless I exert a force on it. If I exert a force on it, the movement changes. This also applies for things going round in circles. Think of the moon going round the earth. What keeps the moon going round the earth? A force. If there was no force, then the moon would spin off into outer space, and the force that keeps the moon going round the earth is gravity. And if gravity disappeared, now I have to try not to hit the camera, if gravity disappeared, the moon would whiz off into outer space. It tells us that if an object is already moving, then it'll continue moving at a constant velocity, again, unless there's a force on it. So Newton's first law tells us what force does. Now, Newton's second law is mathematical. There's a formula. Force equals mass multiplied by acceleration. And it tells us if I know the mass of an object and I know the force on it, I can calculate what the acceleration will be. If you know the mass of the car or the truck and you know the force of the engine, you can calculate the acceleration of the car. We did it for the Airbus and a jet engine. And Newton's third law tells us that to every action there is an equal and opposite reaction. And we saw examples of that. First of all, the rocket firing up into the sky. A gun shooting a bullet. The bullet goes forwards, but the gun moves backwards. And we looked at a jet engine. We saw how a jet engine worked. And the jet engine works because of Newton's third law of motion. The hot gases coming out of the back push the engine forwards. The hot gases, action, pushing the engine forwards, the reaction. So Newton's three laws of motion, which were first written down by Isaac Newton in the middle of the 17th century, nearly 400 years ago. They are absolutely essential for our understanding of force and movement. Without them, so many things that we take for granted today wouldn't exist. So many thanks to Sir Isaac Newton.